Alaikum wa rahmatullahi wa barakatuh. Today, inshallah, we're going to continue solving topic 2 mechanics, paper 1. I'm going to start with mechanic questions, or the questions that is related to mechanic from May 2021, and then we'll go continue solving the rest of the work sheet I shared with you on Google Drive. Okay, now the first question, we have a student measures the length M and width W of a rectangular tabletop. What is the absolute uncertainty of the parameter? Now, how can I calculate the parameter? You add all the length. So you have the width plus length plus width plus length. I have 2 width and 2 length, so it will be 2 times length plus width. If I need to find the absolute uncertainty, if you have addition or subtraction, always you add the absolute uncertainty if you have addition or subtraction. So absolute uncertainty for the parameter will be delta L, it's twice delta L, and delta W also twice. Now, what is the uncertainty for length? This is the original length, and this one, the uncertainty part. For width, this is the original width, and this one is the uncertainty part. So for delta L, it will be 0.1, and delta W, or the uncertainty in W, is 0.2. So 2 times 0.3 will give us 0.6. So the correct answer is 0.6 centimeter. Question 2, you have a minute hand of a clock hanging on a vertical wall that has length from here till here. This length is 30 centimeter. This is L. Now the question, a minute hand is observed pointing at 12, then again 30 minutes later when the minute hand is pointing at 6. So at the beginning it was pointing at 12, and then 30 minutes later it's pointing at 6. What is the question? What is the average velocity and the average speed of the point B on the minute hand during this time interval? Now, average speed is a scalar quantity. I don't care about the direction. While vector, it's while speed, velocity is a vector quantity. So speed is distance over time. Distance over time. I went from the minute hands, went from 12 till 6. So this is half a circle. Half a circle. The circumference of a circle is 2 pi. 2 pi r, half of the circumference. So divided by 2. So it will be 5 times the radius divided by big time. The radius is 30 centimeters, so it will be 5 times 30 divided by 30 minutes. Time is 30 minutes, so divided by 30. So this will be 5 unit centimeter per minute, because this one is minute, centimeter per minute. This is the speed. Now the velocity, it's a vector. Vector, it's displacement over time. Displacement from where we start. I start from here and I end up here. So the total displacement will be all of this distance. 30 plus 30. This one will be the total displacement. So velocity is displacement over time displacement will be 60 divided by 30. This will give us 2 centimeter per minute. 2 centimeter per minute. So the correct answer is A, velocity 2 centimeter per minute, and the average speed 5 centimeter per minute. Question number 3. You have a block rest on a rough horizontal plane. Rough, that means we have a friction. We have a force P is applied on the rock, on the block, and the block moves to the right. So this is the direction of motion. There is a coefficient of friction, dynamic friction, mu d, giving rise to a frictional force between the block and the plane. So here, this is a frictional force. If the force P is double, will mu d and the friction force be unchanged or greater? Now, the friction force is dynamic friction, because the object is moving, equals the coefficient of dynamic friction times the normal force. Now, in our case, normal force is opposite and equal to the gravity. So the friction force depends on the type of the surface and normal force only. So if we double the applied force, nothing will happen to the friction force. So mu d and the friction force will be unchanged. Okay. Now, question 4. Here we have a projectile motion is launched at an angle above the horizontal with a horizontal component velocity VH and a vertical component velocity VV. So we have a horizontal, that means in X direction, and vertical, that means in Y direction. And projectile motion, we have a projectile motion. Okay. So projectile motion, if we draw a relationship between displacement and time, it will go in a parabolic shape, up and then down. Okay. Now, this is the velocity. Velocity is tangent to the curve. The vertical and the horizontal velocity V in X direction doesn't change. It's always the same value. While in the vertical direction, we start up with maximum velocity, and then the velocity will decrease till it reaches here 0. So here I will have V in Y direction equals 0, while V in X direction doesn't change, it's always constant. And then the velocity in Y direction will start to increase again. V in X direction doesn't change till it reaches the maximum just before it hits the ground. So since it's horizontal, V horizontal should be constant. That means I'm looking for constant number. This one doesn't change. So V horizontal or Vx is constant. I start with maximum for Vy, and then I reach 0. Here is 0. Then it changes its direction. So the correct shape or graph is D. Okay, number 5. We have a person with a weight 600 Newton, stands on a scale in an elevator. What is the acceleration of the elevator when the scale reads 900 Newton. The weight of the person is 600. The reading of the normal force is what the scale reads. This reading can be fluctuating, depends on where the elevator is moving up or is moving down. If the elevator is at rest, the normal force and the weight will be balanced. So the scale will read the weight of the person. In this case, will be 600 Newton. But since the scale increase, that means the normal force increase. The normal force up is greater than the weight down. The elevator is moving upward. Forces in direction of motion will be positive. Forces in the opposite direction of motion will be negative. So the formula, F net, all the forces, this is Newton's second law, all the forces acting on the object will equal mass times acceleration. So Fn minus Fg, this will be m times a. Now, normal force is 900, this is Fn, 900, minus Fg, 600, will equal, if Fg equals 600, and I know Fg it's equals m times free fall acceleration. If I assume free fall acceleration is 10, so 600 divided by 10 will give me the mass. M is 600 divided by 10 divided by g, so it will give me 60 kilogram. So 60 times m. So it will be 300 divided by 60. So the value of air, 300 divided by 60. This will be 5 meters per second upwards, the value of the acceleration. Okay, question 6. You have two identical blocks, each of mass m and speed v, travels toward each other on frictionless surface. We don't have friction. Blocks undergo a head-on collision. What is definitely true immediately after the collision? Now we know momentum is conserved. Momentum before equals momentum after. This is the conservation of momentum. Now this object is moving to the right, so the velocity is positive, and this one is moving to the left, the velocity will be negative. I know the momentum, it's mass times the velocity. So the first object will be m times v minus the second object, or also m times v, okay? And the object will stop. Two identical blocks, they travel toward each other. After they hit each other, the final momentum will equal 0. They will stop. So the initial total momentum, since final initial the equal should be equals to what? 0. Okay. Last question we're going to solve, which is related to mechanics, is question number 7. We have the graph shows the variation with distance of a horizontal force acting on an object initially at rest, moves horizontally through a distance 50 meters. A constant friction force, okay, 2 Newton opposes the motion. What is the final kinetic energy? The final kinetic energy of the object after it has moved 50 meters. Now we're going to solve the conservation of energy to solve this question. Conservation of energy, work applied plus kinetic energy initial plus potential energy initial will equal kinetic energy final plus potential energy final plus the energy lost as heat. Now the object initially was at rest, so I don't have kinetic energy initial. So this is 0. There is no height, so there is no gravitational potential energy. We will have kinetic energy final because the object moves. There is no potential energy, and since I have a friction, so we will have energy lost due to friction. So the equation will be W will equal kinetic energy final plus energy lost due to friction. Now we need to calculate W first and then the energy loss. W, I need to calculate the work and then energy loss due to friction. Work, since I have relationship between the horizontal force and the distance, and I know W equal F times distance. So all I need to do is just find the area underneath the graph. So the area we have the piece, this from here till here, 5, okay, times height 18. Okay, and this will give us 200. And since I have 3 shapes, so 200 times 3, total work, 200 times 3 will equal 600 joules. Now we need to find the energy lost due to friction. Energy lost due to friction will equal force also times distance. Cosine the angle between them. Now the value of the applied force, of the friction force is 2 Newton. The value of D is 2. Total distance is 50. 2 times 50 will be 100 joule. This is the energy loss. No need to put negative or a negative sign. Just calculate the value. Now I need the kinetic energy. So we go to this formula now. This one. So the kinetic energy final will be work applied minus the energy lost. So 600 minus 100, this will equal 500 joule. So the kinetic energy final is 500 joule. Okay, let's continue with the worksheet. Last time we reached question number 65. Here we have elevator. Okay, elevator and its load have a total mass of 750 kilogram and accelerate vertically downward. So the direction of acceleration downward, and it's given to us the value of the acceleration is 2 meters per second square. What is the tension in the elevator cable? Now, when you have questions related to forces in Newton's law, first step, you draw the free body diagram on the object. Now, you have the elevator. Since you have a cable, so the type of force here is tension force. Okay, and downward here, I have Fg, or weight. The direction of motion, acceleration, is downward. That means forces in the same direction of motion will be positive. Forces that are opposite to the direction of motion will be negative. And then you applied Newton's second law. In Newton's second law, F net equals mass times acceleration. What are the forces acting on the object? I have Fg down, positive, minus P, negative, will equal Ma. Now the value of Mg will be mass times free fall acceleration. Mass of the elevator 700 50 times 10. So it will be 7,500 minus t. This will equal 750 times the acceleration is q. Okay. Now rearrange, take this to the other side and multiply both sides by negative to get rid of negative t. So t will equal 7,500 minus 750 times 2. This will equal 6,000 in Newton. This is the value of t. Okay, so it will be 6 kilonewton. 6 kilo in Newton. Okay, now we'll go to question 75. You have a ball of mass 0.2 kilogram, strikes a force sensor and sticks to it. Just before impact, the ball is traveling horizontally at speed 4 meters per second. So we have here the speed, and this is the mass of the ball. The graph shows the variation with time, T of the force recorded by the sensor. T here is a millisecond. I need the value of the maximum force. So from Newton's second law, F equals change in momentum divided by change in time, mass times change in velocity divided by change in time, cross multiplication, F times delta T will equal M times delta V. F times delta T, this is the impulse. And this will be equal to the area underneath the graph of force versus time. So this one is I, the impulse. So we have to calculate the area. The area will be half. Phase is this distance. From here till here, I have 440 minus 400, this distance, milli times 10 to the power negative 3, times the height. The height will be Fx, F maximum. Okay, and this will equal M times delta V. M is 0.2 and velocity is 4. So it will be 0.2 times 4. If you calculate this one, you should get 0.02 F maximum will equal 408. Divide both sides by 0.02. So the maximum force will be 40 in Newton. 40 Newton. Okay, now question 77. We have a horizontal spring of spring constant K, and negligible mass is compressed through a distance y. So you have the spring is compressed through this distance y. Okay, from its equilibrium length, an object of mass m that moves on a frictionless surface is placed at the end of the spring. The spring is released and returns to its equilibrium length. So the spring starts to vibrate back and forth. I need to find the speed of the object just after it leaves the spring. Okay, so we're going to use the conservation of energy. The initial energy we start up with is elastic potential energy, and since the object start to move, so the final energy will be kinetic energy. This will be half the spring constant times delta x the compression distance. This object is compressed, so this distance compressed distance y, so it will be times y squared. This will equal half m times d squared. Half and half, we cancel out. Okay. So I will have a y squared equals m times d squared. Divide both sides by m, and take square root for both sides. So b will equal square root k over m. Y squared under the square root will be y. So the correct answer will be A. Okay. Now we'll go to question 80. If you have time, we'll go back to these questions that we're skipping, but I'm not skipping them because they're not important, because they're easy, and I'm sure you know how to do them yourself. Even the questions I'm doing, but some of the questions they have trick things that you need to understand before you solve them. Now this question 18. Let's do the question first. You have a block of mass 1 kilogram, rest on a trolley. So you have a block, rest on a trolley. The trolley, it has mass 4 kilogram. So this is the mass of the block and the mass of the trolley. The coefficient of dynamic friction between the block and the trolley. So this will be mu d or mu k, kinetic friction. Now a horizontal force, the value of the horizontal force is 5 Newton, acts on the block. The block slides over the trolley. So this block starts to slide over the trolley. What is the acceleration? I need the acceleration of the trolley, not the block, the acceleration of the trolley. Okay, now let's first, what are the forces? Free body diagram. Always first step, draw the free body diagram. So I have Fg, the weight of the block down, and here Fn up. Since I have more forces in this direction, so we have friction, dynamic friction in the opposite direction. Now, how can I calculate the value of dynamic friction? Will be mu d times the normal force. In our case, Fn and Fg, they're equal. Fn is balanced with Fg because I don't have motion in the y direction, in the vertical direction. So this will equal mass times free fall acceleration. Okay. The mass of the block is 1 times 10. So this will be Fn. Fn is 10 Newton. So Fd will be the coefficient of dynamic friction, 0.3 times 10. This will be 3 in Newton. For every action, there is opposite and equal reaction. So since the friction force on the trolley is 3 in Newton, this direction, this will equal 3 Newton. I will have a reaction force. This is from Newton's third law. A reaction force on the opposite direction. The value of this reaction force will be also 3 in Newton. So to find the acceleration on the trolley, now I'm going to apply Newton's second law on the trolley. Okay, so Newton second law, where on the trolley all the forces acting in the object, F net equals mass times acceleration. Now, what are the forces here in this direction? Is it 3 Newton? Mass of the trolley is 4 times the acceleration n. So it will be 3 over 4. The value of A, divide both sides by 4. So A will be 3 over 4 meter per second squared. 3 over 4.75 meter per second squared. Okay, question 82. You have a block rest on a frictionless horizontal surface. And I don't have a friction. Okay. No, this one is easy. Let's go to 83. Question 83 and then 84. 83. Okay. You have masses X and Y rest on a smooth horizontal surface and are connected by a massless spring. So I have two mass. They're connected by a massless spring. The spring doesn't have mass. Mass X and mass Y. Okay. The mass of X is 3. So mass X is 3 kilogram. And mass Y is 6 kilogram, double. The masses are pushed together each other until the elastic potential energy stored in the spring is 1 joule. 1 joule. The question is, the masses are released. What is the maximum speed reached by mass M? What is the maximum speed? Now, first, we're going to use the conservation of momentum to find the value of the velocity. And then we'll use the conservation of energy to find the value of Vy, the velocity of mass Y. So conservation of momentum, the initial momentum will equal the final momentum. We know momentum is mass times velocity. At the beginning, both of them, they were not moving, so the initial momentum 0. And then they start to move in the opposite direction. So mass X will move to the left. The velocity here will be negative, Vx. And mass Y will move to the Y, to the right direction. So the velocity of object Y will be positive. So this will equal M mass of object X times the velocity of object X plus mass of object Y times the velocity of object Y. So 0 will equal Mx is 3, velocity of object X is negative direction, plus My is 6, the velocity of object Y is in the positive direction. Take this to the other side, will be positive. So I will have 3 Bx equals 6 By. Divide both sides by 3. So divide by 3. Divide by 3. B in X direction will be 2 B in Y direction. I will keep this one because we will need it when we use the conservation of energy. So from the conservation of energy, I have initial energy, it's elastic potential energy, will equal final energy. I have kinetic energy for both objects. So I have kinetic energy for object X and kinetic energy as well for object Y. Elastic potential energy stored in the spring was what? 1 joule. So this is 1. We equal half. M is 3 times Vx squared plus half. M object Y is 6 times now Vy squared. Now, what is Vx squared here first? Vx squared is 2 Vy. 2 Vy. So I can remove this one first. Okay, and substitute. With Vx, it will be 2 Vy squared. So I will have 4 Vy y squared. Okay. Plus half 6 times by squared. Okay. So we have here 1 equals, after we simplify all of this, we will get 9by squared. I need by, divide both sides by 9. So by, b1 over 9 under the square root. You should get 0.33 meter per second. So the correct answer is B, 0.33 meter per second. Okay, now the last question. Question 84. I'm going to solve this question. Okay, we'll take it here. Okay, you have a cyclist rides up a hill of a vertical height 100 meter. So here you have a flying surface, and suppose this is the cyclist. It's moving up. The height is 100, so the height is this one, 100 meter. In 500 seconds, so time 500 seconds at constant speed. Okay, the combined mass of the cyclist and the bicycle is 80 kilogram. So M 80 kilogram. The power developed by the cyclist is 200 watt. Okay, so this is the power N, 200 watt. What is the efficiency of the energy transferred in the system? Okay, now to calculate the efficiency is power out over power in, work out over work in, or energy out over energy in times 100%. Now, since I have power, I know power is energy over time. So if I need the energy, it will be power times time. So from here, from this one, I can find Pn, the original energy, will equal Pn times T. Pn is 200, time is 500. So energy N will be 100,000 joules. Now I need T out. I need energy out, sorry. Energy out. Now, since the object is moving up, so I will have a change in the value of the gravitational potential energy. Gravitational potential energy is mgh, mass times free fall acceleration times the height h. The height is 100 meter. The mass of the object is 80. The bicycle, the cyclist and the bicycle is 80. G is 10. H 100. And this will give us 8,000. Now we can find the efficiency. So efficiency, E out, which is 80,000, this number, 80,000 divided by 100,000 times 100%. Okay, and if you calculate this one, you should get 80%. 80%. So the correct answer is E. I'm going to stop here. Okay. And good luck.